Good day everyone and welcome back to the channel. In this video I'm just going to do a little bit of transistor matching and then I'm going to get on to another video, but let me just explain what I'm doing. So in a previous video I had sorted out, matched some input pairs, or two of them I think, yeah, two, and no current mirrors, and I said I was waiting on some transistors. They turned up, and because they turned out to be genuine, I've ordered some more. Only another 20, but I mean that'll be plenty. So what I thought was, after I checked the gain on these, it was a little bit higher. It was about 430. I've been doing some thinking about it, and like I said in the last video, I don't want the gain ridiculously high, like 600-700, but I don't want it too low either. So I'm thinking about using these instead and just doing all 4 sets out of these. They're all the one batch, so they're probably going to be, more closely matched to each other. The only problem is they're not matched to each other. So what I was thinking is, because my drawers only got a lot of 992s and not many 1815s. So what I'm thinking is I might be able to make enough matched sets between the two drawers. I hope that makes sense. So some of my 992s with some of these 1845s. I don't know, we'll just have to see how we go. I can only do the best with what I've got. I guess I could also look at using some different transistors. I've had a few other things rock up that I ordered, like these are 2SA970s and 2SC2240s. We could use those. I do have these other transistors, the 1268s and C3200s. So I've got some options here. Yes. Anyway, I'm going to try with what I planned on using first. Oh, that's the wrong drawer. Oh no, 992. I saw 92 and I thought they were MPSA 42s and 92s, because I finally bought some of those, the nice old school Motorola ones. You can tell they're legit, and no, there's no steel legs or anything. They're proper. Right, I'll get a piece of paper on the bench and we'll start potting these out. Alright, first thing I have to do is work out what I can use. I did put these match sets that I already made up aside, because there's no point in mixing them back in. I mean, I'm only going to need to rematch them. I'll just take a quick measurement and see if these, or what these are, and I'll make a note of that. I'm not worried about using 2 different brand of transistors, as long as it's all the same brand on one amplifier module and all the same brand on another amplifier module. I just don't want odd parts in the same amp, but I still want the gain and everything to be the same. So these are around 350, that's right, that's what I thought they were. That's the 1845. That's a 992. I'll shut the door in a minute. That cat's going to be quite annoying. So yeah, that's 365. These are all around 350. So I've got 2 input pairs matched if I wanted to use them. I'm just not sure about it yet. So the main problem I had with this was I had not many 1815s in there. And then to make it even better, when I pulled some off of another board, which is what these ones are over here, they had, I think it was too high of gain. Yep, these are the 4. Let's see what we've got. I think these were like 400 or 500 HFE. That's the thing about transistors, you can have a lot of them, but it can be hard to get what you need. 560. Let's see if these are all the same? I'd say they are because they're all on the same board. They're all from the same batch probably. That's usually how things work. Yeah, these are all up there. All right. I'll just put those off to the side because they're all from one batch. And I do have the PCB down on the floor, so there's another possibility. Actually, that's a good idea because I still need current mirror transistors. You know what? They'll do for the current mirror too, although, you know what, I really don't want too high of gain down there because that could really start oscillating. Yeah, no, we won't do that. Let's see. I'll grab all the 1.845s out of here and just go through them and see if there's any around 350. You never know. $430, $435. I don't think I'm going to be lucky after seeing that number already. Yeah, no. But you never know. You know, I really only need 4 that are at 350. Oh. Okay. 386, that's, you know, we're looking more positive. We're going the right direction. Wow, 378. It seems as I'm going down this line, they're getting smaller. And you know what's good about this? This was a whole long strip that I cut up myself, which means, oh, I'd say that would be the next piece. So let's see if that's a little bit lower. Knowing my luck, it won't be. It'll be like 500. Let's see. It's higher. Don't you love it how things just work like that? $377. So I mean, there are some that are around $377. I could use those. I'm pretty sure I did have some 992s with a higher gain on them than 360. Can't remember. We'll have to have a look. I do have more of these arriving by Monday, Tuesday at the latest, something like that. Maybe Wednesday. I should have it. I know my capacitors are going to be here on Monday. I've got 47 mic and 100 mic at 100 volt on the way. I actually ordered 4 different values, but 2 are just for my own stock. I think I grabbed some 220s and some 470s also at 100 volt. Because I've got a lot of 400 volt caps and 250 volt caps and 63 volt caps and a few 75s, but not many hundreds. Which I've just realized that's a bit of a problem when I started building this amp, so thought I'd better do something about that. Yeah, these might have a couple in them that are, you know, 370, something like that, but not a whole lot. I could always order more from different sellers and get different batches. There are a few different batches out there that I've seen. It's not like this is expensive buying these, you know. I mean, I can't remember what it was, but yeah, it was nothing, you know. Like, I'm pretty sure I probably spent about, I don't know, $10 on them or something. What do I get? 4, 8, 12, 16, wait, 4, 8, 12, 16, 20. Yeah, 20 of each. Alright, well those are all seeming to be the same. Let's see. Let's just take a couple of random from this pile. I tested them before, I think these were lower. Wait, what? Are these matched? No. No. No way. Am I that lucky? VBA 693 on these ones. $696. You know what? I say we do it all out of these. Why not? I mean, seriously. I might as well just leave these all out. I'll leave them on the cardboard because it will add thermal mass to it, which will hold them all at the same temperature better, which is what you want for matching. What I'll do is I'll spread them out on the bench now like this. And then I can just write down on a piece of paper the numbers and go put the strip next to it after it's tested. And then I can choose the ones that I want. So yeah, I'll just do that. I'll put these two input pairs back away. Look, we're building another couple of amps pretty soon. So these will just probably get used in that because these are damn good transistors and I doubt that I've got better transistors in here. I've probably got surface mount transistors that have got better properties than these, but in terms of TO92, these are probably some of the best I've got. So definitely put them just back in there like that and keep them for the next build. And I guess these are high gain ones I can put back in too because, well, I'll put them in a little bag. But the thing is, I've got enough of those here with the new ones that I just bought, so I'm not going to really need them either. I'll just pause the video whilst I sort all this out. Alright, so now I've got all my empty bags ready. Let's go. I might end up desoldering all the 1845s off of that board then, because if these are all around that gain, I don't want to go take a whole load of these and not take, like, I'm not explaining this properly. I don't want to make the numbers uneven. If these are so well matched, I'd like to keep them for matched purposes. So I don't want to go rate a whole load of 1845s for current mirrors that are only made of 1845s and no 992s. I'd rather take those 1845s from a separate place and keep these together to use in matched sets. Alright, now I know you're all probably thinking, is this all the video is going to be? No, it's not. I've got something else interesting to do. I've been waiting a while for this, and the last batch of tip 41s and tip 42s arrived when I bought a couple of boxes. I'll just go grab them, hold on. Alright, I bought a couple of transistor kits, those cheap ones off Aliexpress, and I got 2 of each. This was one of them, had tip 41 and 42 in it. So I added them to my already fairly big collection of tip 41s and 42s. And then I went through them all and put them all in separate drawers for each batch. So what I've now got is that. Don't worry, I'm not trying to show off or anything. And then that, which was my J-car bought ones from years ago. And just ignore that in the back and that in the back. These are different transistors. These are, they're still tip. This is a tip 122. Sorry, yeah, 122. And this is a tip 137. So it's only that, and that. So what I thought we'd do, because I've got, you know, ST, tip 42, on semi, tip 42, and tip 41s, but they're all ST, I think. Yeah, they're all ST. Let's delid and let's compare. Now, the other thing I wanted to do was I wanted to compare it on the curve tracing abilities of this. But I've been trying to work out how you would identify, say, a real transistor from a fake that's claiming to be the same transistor. Because the thing is, the gain changes the curves so much. And let's go to the computer for a moment. All right. What we have here, let me just lock my screen. That's better. Here's my computer. I'm just plugging the peak in. Now, I've been trying to work out what sort of a plot is going to show a difference in the transistor. And I've already had a look at this. And the thing I've noticed is that different transistors that have different gain, you know, it doesn't matter what plot you trace. Let me just get the thing up and I'll show you. I'll just put one of my brand new ST parts that I bought from J-Car on there just as a test subject, or a reference, should I say. Alright, that's got an HFE 114. Now, we can plot BJT, collector current versus voltage collector to emitter, HFE versus voltage collector to emitter, HFE versus collector current versus voltage base to emitter, collector current versus base current. Now the problem I've noticed is that all of these things vary with HFE pretty much, except for HFE versus VCE. That doesn't really vary too much, but it still varies. How do I explain this? Its position on the graph will vary because the transistor's still going to have different HFE. So what I'm trying to get at is everything changes with HFE. So the only way I can think of doing this is to basically measure a whole load of, say, tip 41s that have got the same HFE, but they're different brands and batches, and then see if they test the same. So that's what we're going to do. So I'm going to take some quick measurements and work out what I need as a sample that's got the right HFE, and then we'll do that, and then we'll see how the rest weigh in. Alright, the first one I'm going to do, it's a tip 42 and it's got an HFE of 125. This is my guaranteed original. So what I'll do is this is auto set, it auto sets itself. I'll just start this for each thing. You know, I can't start this until the one before it's done, so I'll wait until these are done and I'll pause the video whilst they're doing, and then I'll come back, we'll have a look at it quickly, and then we'll start the next one, which will be a fake. Now we've got a few different devices to compare, so I think I'll do all the 42s first and then the 41s second, just because I've already put a 42 in there now. It's going to get confusing doing NPN and PNP together. So I'll do the 42s first. Alright, well, that's that done. So we've got our curves. So we'll just go and do our next device now, which is our suspected clone, but it could be an original one, who knows. The reason I think these are clones, I'll give you guys a good look at them all afterwards, and we'll discuss all the different little intricacies. Some look really original, some look really fake. I'll just hit auto set again because the HFE is about 10 off, and it does make small adjustments. Yeah, it appears to have changed things very slightly. Interesting. Well, this is promising. I will say this, I have got no problem with buying clones. Well, let me say this. It depends what I'm looking for when I'm buying it. If I'm going on Aliexpress and I'm looking for a transistor, and I don't care if I come across a batch of real transistors or some good quality clones, I'll buy either. Then I don't care what I get. If I go out looking for a real one and pay good money for a batch of real ones or new old stock or something, and clones come, then I'll be pissed. I hope that makes sense. So in the cases where I've bought these, some of them I've bought as real ones and they do look real. I'll show you guys pretty soon. And the rest came in all those kits, and I expected them to be clones or whatever you want to call them, copies. You know, so I've got no problems here as long as they test, you know, how they're supposed to. As long as the die is the right size and it's got the right curves, I'm a happy man. You know, it's got to have the same voltage breakdown, saturation voltage as well, all that sort of stuff. But I've already tested breakdown voltage and saturation voltage, and they all fall within the spec. So, yeah. This is actually looking quite good because, like I said, this transistor's got 10 more HFE, and as we can see, it's up by about 10 or 20. Yeah, 10. And the line is still linearly following the other lines. I would say that's basically exactly the same. So I'm quite happy so far. I'll pause the video and I'll come back when this transistor's done. Aha, now here we see something different. Now that tells me that that's a different transistor with a different die size, because why would the HFE, if it's only 10 apart, you know, one's around 120, one's around 135, why would the line have a different slope to it in regards to collector current? I think I have two different transistors here. That's quite interesting. Okay, so this might actually be useful. I'll remember that. HFE versus collector current. Actually, I'm going to make a note of that right now because so far that's shown the most difference. HFE versus, I see. All right, let's continue. Well, that seems quite similar, but I don't know. Oh, I see. Collector current. Hold on. I'm trying to work out how to read this. So it's, yeah, collector current versus the voltage between base to emitter. Yeah, okay, no, these are different. Okay. But this shows me the most difference, if you ask me. I mean, this transistor, the gain goes up quite a bit with collector current. This transistor, the gain's really linear the whole way. The funny thing is, that's a better transistor for audio, and that's the clone. That's hilarious. Go figure. I'm not quite sure what to make of that. Let's hit this last one. I gather this is not going to show anything. It looks like this is what's going to show the most, which is funny to me because I was actually thinking that this was going to show me the least because all the transistors have a different HFE. I was thinking that that's going to skew it, but yeah, it's HFE versus collector current. I guess different transistors will have different properties there. I would think, but the more gain a transistor has, that would change. I don't know. I'm not too sure. This is interesting. All right, well, let's delid one of these. I'll just show you guys why I think this is a fake too. All right, so I've got a few different transistors here, but this is a 100% legitimate on semi. All right, see the markings on that? That's what it's supposed to look like. It says TIP 42CG. It's got the on semi logo in a circle, and it's got some numbers and letters next to it. And that's what the tab looks like. Now I got these ones, which look totally different. And there's no CG, it's just C. So I have to wonder, are they fake? So we're going to delete this. This is what we just tested. But then at the same time, I also bought these ones. These were the ones I bought. I bought these in NPN and PNP. So there should be another lot of these somewhere. 41s and 42s. Oh no, these came on semi with the 41s and Fairchild with the 42s. That's right. Maybe it was them. I'm not too sure. Anyway, so yeah, that's that. If we compare these ones, yeah, original versus the one I bought, you'd be inclined to believe that that's original, right? I guess the stamping is still different, but it could just be, you know, it's made in a different year most likely. So, yeah, interesting. What else have I got? Got Farnell. Every time I say F, I could say Farnell. Fairchild, which you can probably buy plenty of Fairchild products from Farnell. Well, not probably, you can. H427, H247. Like that just, it's almost like they just swapped the letters around. I just find that hard to believe. And then the one in the middle, it just says 448. There's no letter in front of it, which is the right way. You know, they don't, I'm sure they don't do it both ways. So, yeah, this can be quite interesting. Now, the reason I want to delid them, sorry, I'm just trying to read the numbers and put them back in the right drawers, is because I've built my amp using some of these, you know, so, and I didn't, well, the only batches I know are real. I mean, let's face it, even these could be fake. They just look real. I think they're real. I think that these ones and these ones are real. And I know my ones are real. But I don't know. You know, honestly, any of these transistors could be fake. And then I've got these ones too that this is just hilarious. What even is that? But again, I mean, that's not copying anything. So I don't have a problem with that because it's not lying to me trying to say I'm made by someone when it's made in some Chinese factory. It looks the part. So again, as long as it behaves, I've got no problem. So yeah, well, let's continue testing them and then start deleting, and we'll come to a conclusion, I'm sure. My apologies, I've just made the screen a lot bigger. I don't know why I didn't do that before, but look, it looks like this plot's going to be the helpful one. I guess maybe I should take some transistors out of the same batch and compare them to themselves and see if this changes. Although no, it wouldn't. It's HFE versus collector current. That's indicative of a different transistor, I'm sure of it. I mean, why would the HFE be more linear versus a few more milliamps with one transistor compared to the other one just because it's got 10 more HFE? No, I don't think so. I don't think so. That's a different transistor. All right, well, let's just keep doing tip 42s. So that was an on semi with the batch number L21XN on it, and I already thought that was a fake. I'll just put my real ones back in the drawer for now. So I've got tip 42 that's supposed to be fun. Fairchild, and tip 42 it's also supposed to be on semi, but it's in a different package and it looks real. Let's try that first. Let's try the on semi package that I bought off Aliexpress that looks real, but like I just showed you, it's got the right logo and numbers and everything, but they're in a slightly different spot. Let's try that and let's see how that looks on this graph. Now this has got a way bigger HFE. This is coming in at 227, so I don't know if that's going to affect it. I hope not. I mean, obviously it's going to be way further up, so we're going to have to... Wait, can't you go up and down on this? You've got to be kidding me. Oh, that's so annoying. You can only scroll. To get to 227... Oh man, we're not going to be able to see shit. Okay, let's just start and see what happens. Yeah, exactly what I thought. Oh, wow. That is so different. So maybe it is the gain that's causing it to look so different. Although no, because this one has more gain and it's flatter than this one. But then when we go back up, the one that's got even more gain goes up again. See, that doesn't make sense. I think this is the best definitive graph to bust fake transistors. Man, now saying this, I'm going to have to pull the transistors back off my heatsink because I want them to be matched in terms of performance. I can't have, you know, one transistor doing this and the other one doing this. They've got to both be like this or like this. I don't even want that at all. That's just ridiculous. Wow. That's amazing. Surely you can go up and down. No, you really can't. That's... Atlas, come on. You've got to be shitting me. That doesn't make sense. Why would they do that? Why wouldn't they make it so that you can just scroll up and down and move the bloody things around? Wait, can you move them? No. Wait, did I just move them? What's going on here? What? I am confused how this works. And now the first two look like they're the same. I don't know what I've just done. Alright, let's Well, that's all I've got in tip 42. Oh no, I've got one more. Let's try these guys. These are the ones that have got no brand on them. Oh man, I really don't know what to make of this now. This has really got me wondering what to make of it. Let's see what this looks like. Oh, I need to reset that. That's not... Oh no, that's right. That's right. All good. Never mind. Okay, this is around the same as the good one that I tested it against. So let's do that again. Oh, I'm doing the wrong plot. I just realized, sorry. We want BJT, HFE versus collector current. Let me just reset everything. I don't know what I did here. That's better. I don't know why you can't just reset it in the program. If you ask me, this program's got a lot missing from it. You know, like scrolling up and down, moving stuff around. Just simple things that would make it a lot easier to compare stuff. This seems different to me. This one, the lines are more spaced out. Or is that just because it's the first one and they get compressed when you do another plot? I think that's what it is. Yeah, that's just more expanded. All right. Maybe we should do a plot like this. Take a photo of it, clear it, and then do one of the suspected transistors. I don't know if that makes a lot of sense or not. I think that's probably a better way of doing it. I've got one definite genuine and 3 I don't knows on the table here. What I'm going to do, I'm going to take a photo of the results of all 4 tests, and then I'll come back, put the photos on my computer and show you guys the results. Alright, so this is quite interesting. I don't quite know what to make of this. So obviously the ones where there's wider spacing, that's because there's more gain, I'd say. Actually, hold on. Look, this is between 110 and 115. This is between 140 and 150. Maybe not. Alright, well, this is a real tip 42 by onsemi. 100% real, this one. And as we can see, the gain's not that flat. And then this one's a real one from ST Micro. Now, it's kind of the same. It sort of goes up more at the start and then flattens out, but it's not really flat anywhere. So this is the Fairchild one I've got, and yep, that looks, you know, it's in the ballpark. I mean, let's say this is on the extreme side and this is on the smaller side between the distance between the lines, but they're the same shape. That falls in that realm. Now, these 2 up the top, these are interesting because they actually seem better. They are more linear. I don't know what to make of it. But then at the same time as they seem more linear, I do notice that there's a little bit of a jaggedy, I don't know what that is that's going on. It seems a lot more smoothed out, even on that green line there. Oh, I guess, yeah, you do get it at the start a bit. Fair enough. Okay, that's normal. I mean, looking at this, I would say that one's legit, like these, and maybe these are not what they are supposed to be, but I would say that that would be a bigger die in there. Actually, hold on a minute. Power devices drop gain with current more, don't they? Or is it less? I always forget. I should do some research on that. Well, we're going to find out when we delid them anyway, but that's the results that have been yielded. So, yeah, I don't know what to make of that. I'm just going to go have a quick look at my amp and see what transistors are in that, because I'm kind of curious. So I've got the L21XN tip 42C, which is why have I not done these? I think I forgot to plot one of them. Hold on a minute. My bad, it's this one here. So that's in my amp on one side. On the other side, I've got the H427 batch of tip 41s, which would be the equivalent of that, because that transistor is the NPN of that, which is the PNP, but I got them together, and that has two. One says H247, the other one says H427, but somehow they appear to be real. So, okay, that looks to be more linear than that. I don't know what to make of it. I think before we do the tip 42s, the tip 41s, let's start pulling these apart and see what we've got. I particularly want to pull apart this one and this one. I'm not going to pull this one apart because it's, I don't know, maybe I should. Maybe I shouldn't. You know something I'm just noticing? Even though this is angled to the side, I don't know that that's actually that flat. Huh. Seems like it's going down, if anything, as the current goes up. Yeah, that's odd. That is quite odd. Well, let's start delidding. Yeah, since we're in this far, we might as well go all the way, because I am aware that different manufacturers have different die sizes. Yeah, that I know that sounds amazing, but it is true that you can get two transistors like the same part number and they can have two different die sizes. So let's pull apart an on semi. This is a legit one. Well, I bought it from J-Car, so it better be legit. No, that's actually the same size as the ST die. I just ruined a good transistor. That was good. You know, it actually might be slightly different. No, that's the same. It's just oriented different. Oh, yeah. Okay, it is a little bit bigger. Interesting. Okay. But I mean, by the smallest little bit, you can hardly tell the difference. In fact, looking at it that way, it doesn't look any bigger. It looks exactly the same. So yeah, no, they're the same. So, kind of sad, because I was hoping I'd be able to use at least some of these. Although, oh, that's the one I just pulled apart. I got happy for a sec. Yeah, so it doesn't look like any of these are going to be any good. Man, TO126 dies in a bloody TO220 package. I'm amazed at how many of them though. I'm amazed. I'm going to have to stop the video. I'm going to have to go have a look on my phone at where I got these from, because the ones that are in the transistor kits, half of those transistors are fake anyway, or clones, whatever. So I was expecting that. But I do have two lots here. Those two, 41s and 42s. And those two that I bought from a seller, or maybe, I think two different sellers. And they're fake. And the thing I want to make sure is that if it's not one of the sellers that I've been getting my real parts from, because that would mean that not only I found a seller that does have real parts, but they've got fake parts too. I really hope they don't. Because I found a seller that I've got heaps of legit parts from that sells the Chinese clone stuff too, but they advertise it as what it is. So they say copy or they say original. And yeah, I'm going to have to go check this, because I'd be really worried if it came from them. I like to make sure that I know what sellers are what, and when I get dud stuff, make a note of it and never go back to that seller. But yeah, let me go have a look at that, and then I'm going to come back and we're going to take a look in some other devices that I'm a little bit cautious of now as well. Alright, I thought I'd take these out too. These are tip 41s. They actually say tip 41 CG, and it's got everything on it that the actual legit ones kind of have. It's in the same format. So, oh, you know what? No, these are clones, because it's a complete circle. The OnSemi logo is a circle made up out of 4 rings, 4 quarter circles. All right, well, just in case, I want to test again on these, and I'll put all the ones that are matched to the side, and we'll pull apart the one that's the odd one, if that makes sense. So if it turns out to be real, I haven't effed myself up. You know what I mean? Yeah, I just had a look at what I paid for them, and I'm actually having a bit of a laugh now. So the ones that I had bought 20 of each, I paid $4.45 for 20. So $4.45, $4.45, and then another seller, I think it was $6 something. I've forgotten the exact price now. So all up, I was down about 20 bucks there, and those two transistor kits were $12 each. So I'm really not worried about it at all, to tell you the truth. It's actually quite interesting to me, because this is something I've been trying to look into for some time, is what's going on with transistors with the clones. Like, are they taking, say, the same TO92 die? I'll explain why I've got this theory. I think I've worked out what's going on with the TO92s. It seems to be different to what's going on with these, which I've just worked out today. I've been trying to work out what they're doing. Are they trying to copy them? Are they even similar in properties? Is it the same die in all different packages? I've done tests on all the different tip series, and this is actually quite interesting. I've measured, you know, they've got inbuilt base to emitter resistors, right? So I've checked like the tip 127s, the 122s, the 137s, 142s, all, I can't think of what they all are. There's more than that I've got, but I've checked all the data sheets for the base to emitter resistor values inside it. And the ones I've got, the resistance checks out for the two base to emitter resistors in series. So that's interesting. It's like they're actually making a die that has, you know, a smaller transistor and a bigger transistor and the correct value resistors, but the dies are still smaller. If you think about it, that is really weird. Yeah, so anyway, the TO92 ones, something I noticed straight away when I was playing with the A42s, MPS A42s and 92s. In plenty of situations, basically, how do I say this? Smoked them, but they didn't smoke. And this is something we're going to take a look at too today. I overcurrented them, put reverse voltage base to admit a base junction, did all sorts of silly things with them. Too much current up the base, and they didn't pop. One, I ran like 6 milliamps through it at 63 volts, and it was like smoking hot, and I could smell it in the room. And I came over and turned the amp off that I was working on, tested the transistor, and it still tested fine. I thought to myself, hold on a sec. I think what they're doing is, for those little transistor kits where they've got like 2N 3904, 3906, 5551, 5401, blah, 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 BC 327, 337, 547, 548, 549, 55, you know what I mean? They put all those A42, A92 all in one kit, you know, usually about the ones I just mentioned, all in like a kit with 25 of each or whatever. I've got a theory that they're not all different dies, but what they're doing is they're just taking, say, a die out of like a little TO126 device or something like that, or maybe the biggest TO92 device that exists, and then just putting the same die in every transistor. Because I've put way too much current through transistors that would normally pop in 2 seconds. I've destroyed heaps of TO92 devices, legit ones, you know. I'm quite used to how quick they go up. And these ones are acting like TO220s in the spot of a TO92, which just doesn't make sense. So, yeah, I'm curious. We're going to work all this out today, and we're also going to work out what we're doing for my amp build. So this video is probably going to become a long video. I'm sorry, but it's also going to be a very interesting video. We are uncovering the mysteries of China, and we are selecting transistors. Alright. You know what? I'll just get the ZIF socket. Alright, I've got a ZIF socket. Something tells me that these are going to be fake. Just seeing that logo. Yeah, that's all one circle they've missed. I don't know why they can never get logos right. Chinese have been cloning parts for so long, and yet they still cannot copy a logo. Like, is it that hard? Blows my mind. It's good for us. Oh, I'll just use that one. Alright, let's see how big the die is inside that. Oh, my pliers aren't here. 1 second. I have returned. You gotta be shitting me. You gotta be shitting me. That's right. Oh, man. These are right. These are... You can't freaking win. I've destroyed, you know what actually makes me upset? The fact that I've destroyed 3 legit devices. Not the fact that I've bought a whole load of duds, the fact that I destroyed the 3 real ones. Oh God. I'm a strange person. Well, that is very interesting, I must say. Well, some of these, the die was small but not really, really small. I'm wondering how big the die is supposed to be for a tip. I don't know, something smaller, like a tip 32 small. They are, aren't they? I think they are. I wonder if they might do in place of those. Because as we saw looking at the curves, some of these devices matched in terms of the curves. You know what? Let's do something. Let's take... Let's take one of these. Oh, you know what? We've still got other batches in here too. Like, because I tested the 42s of the ones that said H247 Fairchild, I didn't choose the matching H427, whatever they are, tip 41s. But, and the same with this L21XN batch, which is the same batch number on both parts. That's hilarious. Am I seeing things? Yeah, no, L21XN on both parts. Absolutely hilarious. I haven't pulled apart this one. This has got just 448 written on it. How funny would it be if this is actually real too? Oh my god, please, please don't let this be real as well. There is an art to not smashing the die in half, but without heat, it's pretty hard to get the die out clean like I was on the back plate before. That's fake. Fake as. Little speck. So funny. So funny. I just don't know why people do this shit, seriously. I mean, yes, okay, don't leave it in the comments. I know why they freaking do it. Money, obviously, but come on. The thing that blows my mind is they've got dies for all different transistors and all different sizes. They have larger dies, they just don't put them in the right packages. Like, if they just... It's not going to cost them that much more. You know, they'd still be making tons of money. Yeah. I just don't get it. Anyway, that's interesting. Alright, moving on. So, something else I want to investigate. Actually, let's do a little bit more investigating on the tip series first, because, I mean, I'm not going to lie, I already know what factory these were made in from the logo. It's supposed to be an ST part, and... Oh, that's just hilarious. Like, seriously, look at it. For those of you that don't know, let me get an actual ST part. Because like I said, mine are actually legit ST parts. So you can all have a nice look at an ST logo. Right, this is what the ST logo actually looks like, right? These are both legit parts, they're just different batches. This is the clone ST. This is what I'm saying. Like, let me get some more. So that one's got a slightly bigger one, but focus. Like, seriously. They've even got the font correct almost. I mean, yeah, that font is correct. But the logo, I mean, it can't be that hard to write S and T on a bit of white. Pay me, I'll do it. No, I wouldn't do it because you couldn't pay me enough money to help someone fake transistors. That's just a bullshit practice and I wouldn't be a part of it. But yeah, I just can't believe that. Well, you'd think after all these years they could write a logo. Alright, well I've got some other transistors that I recently bought for amplifier building. I think these are going to be real, but there's no knowing with Aliexpress sellers. This is why I like to test everything before I use it, obviously. Yeah, I know, haha, I was a bit silly fitting those transistors straight to the heatsink. I don't know why I did that before I looked in them. It's weird. I don't know. Anyway, these are 2SC 4793 and 2SA 1837. I'll get the data sheet up for these. These are the same driver transistors that are in that Yamaha mixer that I've got to repair. Actually, that's a good point. I'm going to go have a look. I'll bring the amp over here. One sec. Alright, here we are. So, these transistors, probably those as well. I know just those. No, just these outer ones. Yeah, sorry, just these outer ones. Let's see. Well, let's look at the back first whilst we've got it here. Okay. Yeah. That doesn't necessarily mean shit. The legs are different. Already we're looking like the clone legs. What do I mean by clone legs? Let's just take a clone transistor. That's what I mean. You just get used to these things. Oh yeah, I'd say there's no way in hell that that's real. But what we can do is two things. We can get a data sheet up and have a look in the data sheet, the power rating and current. That will tell me how big the die is. I'm pretty good with my die sizes. So, I mean, not perfect, but I mean, I can get it within a millimeter. If I open this up and, you know, say this is a 6 amp part and the die is 1 by 1 millimeter like those other ones, it's obviously a fake, right? If it's a 6 amp part, the die is going to be at least 3 millimeters by 3 millimeters or 3 by 2.5, something like that. You know what I mean? You can work these things out. It's like if you open, you know, a TO220 device and there's a TO92 size die in there, you know something's up, unless it's one of those rare parts that's like really, really small in a big package. They do exist for some weird reason, but yeah, you're gonna know it's straight away a fake. I don't, however, know how I would go about opening one of these to find the die. I can't even see like a molded line. Oh yeah, from the bottom I can see it. Okay, so maybe I can pop this open. It's almost like it's been painted, has it? Wait. No. Alright. I'll get the data sheet first, so we know what we're looking for. I'll just pause the video whilst I close all these pictures. Actually, whilst I'm closing these pictures, I've just thought of something that I should mention. Whilst having a look at those curves did show differences, the first transistor at the bottom left-hand corner of those pictures that looked like it was in the same ballpark as the real two that I tested actually had the smallest die in it. So I'll have to look further into that. I've done a ton of Googling the last 2 days to see what you can do on specifically this tool to identify fakes, and there's not much on it, so I'll just have to work it out myself. it's not going to be hard for me to do it because I do have plenty of transistors that I know are fake and plenty I know are real to test between. So, you know, and the same like with gains and all that, VBs, I can get everything the same and then test reals and fakes and look for the differences, and I'll work it out myself, and I'll come back and make a video when I have worked it all out. But yeah, all right, let me get this data sheet up. All right, these transistors are nice transistors, but they're not going to be usable in my amp because they're only 60 volt parts. They are 5 amp collector current, 1 amp base current, power dissipation is only 2 watts. So it's going to be a smaller die than the TIP 42, but it's probably only going to be, you know, a millimeter, maybe half a mil smaller in one direction, the other direction probably the same way. Maybe a mil smaller in one direction and half a mil in the other direction at the most. Let me go get a couple of dies, and I'll show you how big I think it should be. All right, so there's the 3 actual real dies that I've wasted. So what I'm saying is it's going to be, sorry, I thought one of those was a little bit smaller for a sec. One of those might be a little bit bigger. I said that before, but anyway, what I'm saying is basically if you take that die, it might be a fraction smaller than that, but it's not going to be one of those little specks that we looked at that were like 1 millimeter. And just for reference, now you know what I mean when I say it should be about 2 mil wide. You see? I'm pretty good with them. So, I'll go get this really hot and try and split it open. I don't want to waste them in case they are real and they're just made by a different manufacturer. Who knows? We'll find out. Alright, the results are in. That to me looks fake. I mean, it's a lot smaller. But only by a little bit. I mean, it could be the right size. I just don't think it is. Hard to say. Just, it seems about half a mil too small. It is perfectly square in the center. The counterfeit ones are always slightly off. I don't know what to say about that. Let me find out this die size for one of those, because you can usually find die sizes online. I'll be back in a sec and I'll let you know what I found. I'm having a real hard time deciding if that die is too small or not. But you know what I thought I'd do just quickly? I'll do it on the video because this is really funny. I can still see where the bond wires broke off that die, and that die doesn't look like it's broken at all. Come on, you can't blame me. Haha, I got it. Look at that. That's freaking hilarious. That's a junction. That's one. I seem to have bridged the other junction out or damaged the silicon. Yeah. Well, there's one junction. Yeah, I can only get the one junction, but that's still pretty cool. All right, I can't decide, honestly, pretty strong stuff. I can't decide with this. I mean, it looks about the same size as those other transistors that I just pulled apart. So I want to say it's a fake, but it's a 2 watt part. Let me just get the data sheet up for the tip 41. Yeah, the tip 41 is 65 watts. And continuous current 6 amps, 10 amps peak, base current 2 amps. That's another important thing to look at too. The base current on this part is only 1 amp. So for starters, the base junction is only half the size. Secondly, the power dissipation, well, 2 watts versus 65. I don't know, maybe these are real. I would trust them. I would trust using them and find out the hard way if I have to find out. All right, what's next on the list? Okay. The next thing on the list is going to be MJE 15032Gs and 15033. I've got a pretty big feeling these are fake too, which is why I don't have a lot of them. I've been waiting for these to rock up. These are some of the transistors I've been waiting to show up. Now, these and, what was it? Some BD series transistors I bought, I'm pretty sure are clones. But I've got some other transistors that are in the same boat as these, that were sold not as clones, as real original stock. And I'm interested to see what those are. That is these. Now, for all intents and purposes, they look the business. You know, they don't have that telltale... Oh, you know what? I haven't inspected these yet, but I'm just looking at the leads and these might be an older clone. So the thing with the Chinese clone factories is they change every few years. And every few years you get a new batch of what I call symptoms, like all the leads. Now everything's being made out of steel. A few years back they were still using copper. So I was looking at these thinking, oh, well, they're copper. That's a good sign. But I do remember seeing transistors with these legs that they've got this sort of like stamped feel to them, the way they cut out. It's like, it's hard to explain. It's like they're stamped out of a sheet or something. And the middle bit's a little bit thicker. It comes out the bottom. I came across some 649s, D649s, and is it B649 and D669s a few years ago that had this exact same badge on it. I think it's Hitachi. Yeah, Hitachi. These really do look the part, but in terms of the writing, and these are only a TO126 part, so it's really, this is where it starts getting hard pulling transistors apart and looking at the die, because you'll find a lot of TO126 devices, the die is basically the same size as a TO92 device. You can't really tell the difference. And then when you've got parts that are anything from 1 amp to say 5 amps in the same package, and anything from a watt to 40 watts or whatever in the same package, it gets a bit much. But I do want to test these devices. I'll get the data sheet up for these first. See what, you know, the power handling is supposed to be on them. But I can say straight away, again, on semi, just with the circle around them. Although, I will say this. I've got these transistors here that we just realised were real, and that has a solid circle around the on semi logo. Although it doesn't necessarily mean they're real. They could just be good clones, you know, that have actually got the correct size die in them. So I'll get a data sheet. All right, these are an 8 amp part with a power dissipation of 50 watts. So we're expecting to see a die basically the same size as a tip 42 die in here. I already don't think these are correct, and here's why. The marking on the bottom, assembly location, year, work week, right? That's just the same numbers around the opposite way on each part with a different letter and a letter missing on one. Anyway, like I said, they could be like decent clones with big dies in them. I bought them off Aliexpress. I did not buy these as originals, so I really cannot complain at all. Unless, you know, the die's way too small, then yeah, big complaint then. Oh, that's freaking hilarious. That's the smallest one I've seen yet. Wow. I didn't know it was this bad. I mean, they're only cheap, but I mean, I have bought a lot of different types. I didn't expect them all to be rubbish like this. The thing is, I've bought heaps of capacitors, heaps of diodes, heaps of output devices like power transistors, and I've only got scammed once. So that's why recently I started buying all these. I don't understand why you would counterfeit small TO220 and TO92 devices. Why wouldn't you counterfeit the big ones? I mean, I have got some counterfeit output devices, but only one batch. Yeah, same little spec. All right, well, guaranteed fakes. I've been taking photos of all these just so I can try and get my money back. You never know. I'm not too fussed with the... I kind of am now because, yeah, the die size is too small. I don't care if it's a clone, like I said, and it works, but if it's like that, then, yeah, I've got a massive problem with it. All right, what's next that I suspect? Okay, the other ones I wanted to test were these. Not for my amp. This is just me testing stuff to see if it's real. But since I'm in the process of doing it, might as well. The two things I wanted to do was the tip 41s that had the bigger die in them. Oh, I've forgotten which one that was. Oh, God. Let's do them both, actually. Let's take one of these on semi ones that's not on semi, and the Fairchild one that's not Fairchild. Let's bolt them to a heatsink and pump some current through them and see what happens. Let's do the same thing to these as well. Let's see how they all hold up. I'm curious to see what these do. I got good news. Really good news. I had the wrong data sheet up. Check this out. I had 2SA1387. These are 2SA1837 and 4793. This is actually a 1 amp collector current, 0.1 amp base current, 2 watt part. That's definitely the correct die. So that's great. That means these are real. And what's more, they're not going to be any use for driving my output devices, but they will definitely be good for pre-drivers. these have got a collector base, collector emitter voltage of 230 volts. So that's wonderful. I mean, they might be able to drive the outputs, but it would be pushing it. I don't like to go that close, you know. 2 watts isn't much when you think about it. All right, so that's really good news because, like I said, I bought those as real. I didn't buy these cheap. Well, I mean, they were still fairly cheap, but they are a lot more expensive than all these couple of dollar piles that I've been showing you. These I actually paid something for, you know. So I'm happy about that. I'll probably order another 20 because I'm trying to build up a nice collection of stuff for amplifiers mainly at the moment. And it seems these cheap ones are all rubbish fakes. So that's quite interesting because I'm starting to find with AliExpress, it seems if you go on there and buy transistor kits or just these random transistors that people sell that all look the same, they're always fake. But the people that you see with like the transistors in the tape, in the product image, or the old stuff, you know, they seem to always be legit. So I think I've worked out the magic to it other than just trusting certain sellers. But yeah, like I said earlier, even that isn't always good if you don't know what you're looking for, because there's one store that I go to that sells both real stuff and the copy stuff in the same store. It's called CHDX if anyone's curious. I'll tell you one store that I have had good luck with. It's LSX. They're really hard to find just by the letters, but you've got to know the whole store name. If anyone wants to know, I'll tell you. Just I'll have to find it on my phone and leave it in a comment or something. Leave it down there if you want to know. I can definitely tell you what stores to avoid if anyone wants to know too, because like I said, I make notes of all this stuff. Yeah, the thing that's really got my interest, I think these are perfectly fine because I bought them from the same store that I got these from, and these and all the other TO92s that were actually real devices, not all this fake clone stuff. So I got a feeling that these are going to be real. These SP Tech ones, I can't see why these would be clones because SP Tech is an Indian or Chinese, I think it's Chinese actually, company, but it's like one of the legit ones, you know. So I would imagine that this would just be sold because it's cheap already. No one would clone it. I could be wrong. These I got from a store that I get legit stuff from, so I think these are going to be okay. I guess we'll find out fairly soon. These are both 200 watt devices, so that could go quite ugly. Anyway, I'm not here to pull those apart right now anyway. What else do I want to look at? Let me just set up to do some current testing. I think we'll do that now. I've just been doing some reading in the tip 41, tip 42 data sheet, and I've checked a couple of data sheets, and this has really got me curious. Apparently, the HFE is supposed to be within 30 to 75. Well, that means that those other ones that I tested that have got the bigger dies in them, that I said are real, have to be fake because their gain was like 270 something. But now, I'm even more curious because let's just go back to the JCar ones, shall we? I remember a lot of these ST ones being exactly that, 75. Yeah. I didn't realise that these had such small gain. I don't want these anyway. I need better transistors than this for my amp project. I just assumed, man, silly me, I just assumed that the gain was higher because of all the ones I've got. When I went to match them, see, tip 42 CG on semi. Let me get an on semi data sheet up. I'm pretty sure I've got one up right now. Yes, I do. Okay, this makes no sense. It's the same thing. This is the on semi data sheet. I'm pretty sure. Let me just double check. Yeah. What? I'm going to have to do some research. I am really confused now because, come to think of it, even 4 years ago when I was buying them at J Car, I've had gains anywhere from down there at like 40 to 75 up to like at least that, like 160, but I'm sure I've seen them like higher, like those 270 ones that I measured. So I'm really confused now because what, a J Car ordering fake transistors? Like seriously? This is really cause for concern. Now I know why I thought the gain was higher on them. I bought them from J Car. I assumed that that's how they should be, and I just... Alright, I've done some further investigation. Oh, sorry, I should probably just add this. My apologies, my phone just went flat. That's why the video cut off all of a sudden then. These transistors, they've got signs of aging, like copper oxidization through the plating, the tin. I was comparing these with some fake transistors I had that I thought, little man, I'm trying to work. I thought this bigger middle tab in the middle was a giveaway sign. Actually, the fake ones, it's bigger on all three legs. And when I looked at the markings on this, I'll just show you guys. Yeah, they're all there. So I'm going to say that these are real. These are also non-magnetic, they're copper. And the back piece, it's not the... Let me go get some clone TO126 devices. Alright. They look really similar, but if you look at them carefully, you can tell the clone from the real one. So, yeah, I'm happy with them. I'm not going to pull them apart either. The collector current on those is 100 milliamps. I mean, you could fake the dye in that and it would still work perfectly fine. You know what I mean? You wouldn't fake that. So I'm not worried about them. And like I said, they came from the same seller I got these from, as I got those from, as I got the 200 watt output devices from. And the reason I got those from them is because all the devices I've gotten so far that weren't fake when I pulled them apart, like the dye was the right size, that sort of thing, came from that particular seller, which was the LSX Electronics and CHDX, for those wondering, on Aliexpress. I'm going to show you guys something soon in this video on Aliexpress. I don't know, I'll show you, I'll just tell you. Basically, when you look on Aliexpress for transistors, right, you'll see all these transistors that are listed that have, you know, you type in 2SA1667, just an example, right? And you'll see all these listings come up with like a white background and just like a really plain one of these sort of packages, image of that, and it will just say written next to it like 2SA1667 or 2SA1837 or whatever, right? And those are your fakes. Then you'll see some images that actually, I know this is funny because a lot of people, from what I've read on forums, reckon that anyone that's trying to say that their stuff's real or original is selling you fakes. Well, I can tell you now, the people that actually have the picture of the product like this and it looks legit and you can see the print on it, it's not, you know, all the Chinese semiconductors clones. Let me just get some examples of the TO92s. I'm not going to go grab every single drawer I've got, but you can tell, right? It's just really obvious that even when you look at something from a completely different batch, you know that's all the same shit. The numbers are just made up, literally, you know? And anyway, the listings where they don't look like that, and it says import or original stock, and you can see the pictures. So far, I've had no problems buying anything from any of those listings. So that would be my advice to you. It's actually pretty obvious just looking at the listings. Yeah, who would have thought? But yeah, in saying that, I'm still quite confused as to why this one was 278, wasn't it? Or was it 178? 168, I think. I'm really confused as to why the gain is so high on some of these devices that came from JCar. Like, that's 166. That's 75 times 2 would be 150. Yeah. That's over double the data sheet's HFE, you know? I just find that a little odd. I'll put that one back. Have a look at a couple of these, because I remember these were the same thing. They weren't heaps over, but they were like 115, 125, you know. Again, the data sheet said maximum 75. See, 113. Now, I know that's not miles over 75, but still, I'm really just confused. I mean, the die size is correct. Okay, that's the same. Trying to make me out to be a liar. See, 124. Yeah, I'm going to go do some research off camera, see what I can turn up about the HFE. That can't just be because it's being measured at such a small current either, because, I mean, yeah, okay, for, you know, something that says 75 might come out as 100 or 115. I could see that maybe because the current's really small, but, you know, 160, 278, nah, that's a little bit odd to me. So I'll go do some research and I'll come back and tell you what I found. I've been having a look at the data sheet, and from what I can see, that's measured from a collector current of 0.3 amps, so 300 milliamps, up to 3 amps. That is a lot more than the maximum of 10 milliamps that this will supply. Doesn't gain go down with current? But yeah, it does. Oh, that makes sense then. Okay, yeah, okay. If it's, yeah, right, okay. If you're measuring at 300 milliamps and the max is 75, the max could be a lot more at a smaller current. Okay, all right. Okay, that's quite promising. That's good. Good to know. I'm going to do one more thing. Those other transistors that I've got that turned out to be real, which the weirdest thing happened, if you're wondering why the missing one is added back after I pulled it apart, I found one in my bin, put it on the tester, and it was good. Don't ask me. No, there was no more in there. I checked. Let's have a look at the curve on these. Do you remember earlier on when we were looking at curves, some of the dodgy ones, the curves sort of went up. They weren't linear with HFE versus base current. Let's have a quick look at these, just so I know what's real here and what's fake, because I'll keep all my real tip 41s and 42s away separate to these, and all of these fake ones I'll mark as fake, so I know that, you know, only use them in a 1 or 2 amp situation at a really low voltage, you know, for some little project or something. Don't stick them in an amplifier, for example. So I want to know. So we'll take a quick look at this. I'll just set that up, get it to, oops, just threw that on the floor. Get it to do its thing, and then I'll just give you guys a look at the screen. Sorry, it was HFE versus collector current. My bad, I said that wrong. I can already tell looking at that that's linear. Yep. So those transistors are good. That's good. All right, well, I mean, yeah, I'll let that finish and we'll have a quick look at the final result. But basically, that means I've got these transistors. Yeah, these ones. And the ones that I already had from previous batches that I hadn't got from Aliexpress. I don't think there's anything that matches even close in those transistors that I want to use for my amp build, but I will have a quick look off camera now and come back and let you know what the results are, and I'll pack up the rest of these rubbish fakes. Actually, we'll take a look inside the rest of them because I haven't delidded every single one. I mean, might as well, right? Why wouldn't I? We'll do that now. Okay, that curve plot's finished. And do you know something? I'm going to have to run another test of an original because that actually does look different to what I remember. Huh. Do I still have my pictures open? No. Damn. That looks different to what I remember. I don't remember the lines being that close together, and I don't remember it looking that... I don't know, something about this just looks weird. I got cats climbing up on stuff in here. I'll be back in a sec. Yeah. Look at this. I was right. They are fairly linear, but there is that curve at the start, and then it ends up more linear. This is really flat all the way along. So I'm going to put them off to the side. Oh, you know what though? They have way higher gain, which would flatten that out versus collector current. It is the same curve, it's just compressed. I think these are real. All right. That's fine. I'm happy with those results. I'm going to throw these in the bin. I've taken photos of these and sent them to the sellers that sold them to me. Like I said, I'm not too worried because I didn't spend a crap ton of money on them apart from 2 batches of 20 of each. Those I did spend a bit more on. Anyway, I'm almost up to my amplifier, which I've just found something else which has cracked me up. I was looking at some of the other transistors I bought that are not clones, you know, nice legit transistors. There's the 1370s that I loaded the data sheet up for. How funny is that? That's 1370, and that's, oh no, that's a different transistor. Sorry, I thought that was what I typed in when I was looking for these, because I typed in 1783. I can't remember what I typed in. That was the right numbers, but in the wrong order. Anyway, if anyone's wondering, these transistors, and these, I've specifically got because they are nice, old school, known transistors, good quality, really well liked in audio circuits. Those are for my VAS because I don't know yet if I'm going to have to beef up the VAS stage or not. So I got some transistors that are helpful for that in terms of gain, voltage, current handling, all that sort of stuff. Quality. Yeah, so that's what they're for. The only problem is right now I'm without drivers because of this bloody, what do you call them, fake tip shenanigans. So I need to sort something out for drivers now. Bit of an issue. Both the transistors that are on my amplifier, both the NPN side and the PNP, they're both fake because that's the H427. Well, we haven't pulled it apart yet, but we already know it's fake. And that's the L21XN. So I know I pulled apart all the TIP 42s, Let's just have a quick look at the tip 41s, shall we? There's an L21XN tip 41. 448. I think we pulled those apart. I'm pretty sure I did pull one of these apart. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, I pulled one apart. So the 8427. Don't believe I pulled them apart because that's a tip 41. I started on the tip 42s. And yes, guys, I know all the other transistors that came in that little box are obviously all fakes, including the tip 32s, and I'm not silly, I know. I don't want anyone worrying for me, it's all good. I do these things, honestly, half for my own curiosity and half for the channel because I like to, show this sort of stuff. There's too much crap out there, and, a lot of people are none the wiser unless someone shows them, right? I just hope that these videos get out to people that do this sort of thing and help them. So we've got the same little miniature die in there. And this is the 8427. That was L21XN. Yep, an even smaller die. Interesting. Those were both made in the exact same factory. I'm sure you guys can tell just as easily as I can. Maybe not. Maybe not, but it really looks like it. If this were focus, you'll see why I'm saying that. Although one die is smaller than the other one. That's something I've always noticed with fake transistors. I've got a good example of it right here. Anyone remember these? Yeah, I've still got them. I haven't worked out what to do with these because these are these are freaking hilarious. Really small die for the power of the device, but I don't know. Maybe I can use them for something like a load bank or something like that. Just put heaps of them paralleled up with obviously base and emitter resistors. I don't know, but I'll go crack some of these open. I'll be back in a sec. These are absolutely hilarious. So check this out. It's all steel. I mean, the whole thing is steel. Here's a magnet, right? That's not supposed to happen. There's no copper inside it. Even the inside heat spreader, look, it's two pieces of steel. That's steel. Oh, that's stainless steel. What the F? That's a little piece of stainless steel. That's crazy. Why even bother? Wait. Oh, yeah, that's the inside piece. So there's a bit of steel stuck to a bit of stainless steel. What the fuck? Oh, because that's on the back. They don't want it to rust visibly. Sneaky bastards. Man, the lengths these people go to, why don't they just bloody make real transistors? I just don't get it. They put in the same amount of effort to make a real one. They could just put their own number on it and people would happily buy them. I'd buy them by the 1,000 if they did a proper job. Like I said before, I've got no trouble if it's advertised as what it is and it does the correct job. I've just got a problem with this sort of shit. Well, not these, those ones. I'm having a bit of trouble getting into this one. I'll be back. Alright, the reason I wanted to show you this is because like those last devices we looked at where the dies were different sizes, check this out. You see one's got a bigger die than the other one. That's the die that belongs in a tip 41. I mean, obviously I don't know that it's the same die. I'm just saying the size of it. But this is the point I was getting at before. They clearly can get the right dies. Why couldn't they just put that in those packages and sell them as clone tip 41s? No one would be complaining. You know? Even that die there is not that much smaller. But yeah, that's the crap that they do. Alright, so what was I going to do? There was something I was going to do. Have we delitted them all? Yes, we've delitted them all. Alright. I'll have a quick look through here off camera. If I've got matches, I'll use them. If not, I'm just going to go to something else. Look, I've been tossing up this for a while, using a better type of transistor. A lot of people say that tip transistors aren't the best for audio. Like I said multiple times, I can't imagine why, unless it's just because they never matched, because I've never seen a matched set. But we'll see. So I'll go through these now and I'll be back soon. I already know that these are all around 260 to 275, but I don't remember exactly what these are. I know I tested them in an earlier video, but yeah, it's all good. I'll check them quickly. Actually, before I do, you know how we just compared this transistor against those because the lines were really close together on those, and this was spaced further apart? Well, this one's got a gain of 167. What if I take one of these that had a really low gain of like 50 and we plot the curves on that? I want to see if there's a difference between the spacing on the curves between high and low gain. So basically the difference between that. Actually, I should probably do it with the same transistor. Yeah. Let's see if we can find one that's got the really low gain, because I saw some in here that were like 40. There you go, 44. So that's a tip 41. Oh, that's a tip 42. You gotta be kidding me. Oh, goodness. I don't know if I have any. Like I said, I don't know if there's any matches in here or not. I can't remember. I'm about to find out. I guess we're just going to do this live. I'm not going to go through the whole pile. I'll just try and see if I can find a match for that, and we'll have a look at it on the curve tracer. Doesn't look like it. I've only got 2 or 3 batches in here. Yeah, 3. I remember from buying them: CHN122, CHN912, and CHN326. All made in the China factory, 3 different batches of them. The HFE will all be around the same ballpark, so I only need to test these 3. 1, 2, 4. These cats are being annoying. Come on, 112. Doesn't look like I'm going to get a match if those other ones are all around 40, 50. Damn. No. So I don't even have any matches of tip 41s and tip 42s here, surprisingly. That's hilarious when you consider how many I've got. Well, I'm going to go pack up because I don't need these on my desk. I'm going to condense all those fakes down to a lot less drawers. The only reason they were in separate drawers is because, like I said, I hadn't worked out if they were real, and I like to keep separate batches apart. I'll go sort that out and I'll be back soon, and then we'll work out what we're going to use for my amps. I'm either going to be buying transistors tomorrow, or I'm going to be using different transistors, or different transistors that I buy tomorrow. So we'll work that out in a minute. I'm going to put these separate too. After looking at that line, I can't see how all the other tip 41s and 42s I've got here, all the lines have got gaps between them, no matter if the gain's 50 or 160 or 110. And these, they're all close together. So even though it's a bigger die, I'm going to say that these are clones with the right size die, but clones, not originals. Alright, so I've just taken some transistors out of the bin. These have got ruined junctions in them, but these are all those clone type of transistors. I just want to show you guys what they do with the numbers. You see how similar they all are? And look at the transistors themselves. This is why I asked the question, do they just put the exact same die in different packages? Well, let's find out. So, let's take, say, a BD136 and a B649, because they're completely different transistors, especially in terms of voltage breakdown. One of these transistors breaks down at like, I don't know. Actually, no. 649s aren't that high, are they? You know, they're like 160 volt transistors. Yeah. So let's work out the pin out on these. And let's do a breakdown voltage test and see if one fails at, what's a BD136, 50, 60 volt part at the most. I couldn't see it being more than that. A 649 should be 160 volt part. Oh yeah, these are already blown. What am I saying? I'm going to have to waste more good transistors to do this, but so be it. Alright, here's a working 649. Same batch, same crap, just a working one. So, emitter, base collector, emitter. Emitter collector base. If I turn it that way, it's BCE. So, alright, let's see what the breakdown voltage is on that. I'm not sure if this is a PNP or an NPN. Just give me 1 sec. Alright. I can't believe that. I just checked my multimeter and I forgot already. Because I didn't want to stop the video and look online. Yeah, okay. Let's see what we get. That's just a tester, it does that. Okay, so that's where it's breaking down at 200 volts. Just for shits and gigs, let's test that now and see what what it looks like. Why not? Probably hasn't changed, but it's going in the bin now. I've done that to it. Wow. Okay. Let's have a look at the die size in this. This is supposed to be a 1.5 amp transistor. Yeah, my head's a bit of a data sheet. It just takes a while to think sometimes. Obviously only for parts that I've already used. But I do have a good memory like that. Oh my God. Holy shit. That is a TO92 die. You know what they're doing? They're putting the die, the size down. So if it's like a TO247 or a TO3P or something like that, they'll put a TO220 die in it. If it's a TO126, they'll put a if it's a TO220, they'll put a TO126, and if it's a TO126, they'll put a TO92 die in it. I can't believe that. That is hilarious. All right, let's go and keep looking and see if they all have the exact same die size in it. I know, obviously, without a microscope that's high enough resolution to really look into it. Actually, you know what? I do have one. And you don't need that high resolution to look at the top of this. You know, if it's not going to work with all of them, because obviously as I'm cracking them, a lot of the dies are getting broken, but we could... I'll do this in a separate video. I'll get some sort of solvent or something and some heat, and I'll take them apart really carefully, preserve all the dies, and we'll have a look at dies. That'll make for an interesting video, because like I said, I really want to know for you guys and for me what's going on with all these Chinese transistors. You know, like, are they all the same die? Blah, blah, blah. I've got so many questions. And I think now that I've actually started to show a little bit more of what I keep talking about, you guys are starting to see what I'm talking about. Like, this is actually a really big thing that's going on. It really blows my mind, because I've looked on these websites, shops, should I say, on Aliexpress, and I'm seeing like 500 of these things sold, and, you know, heaps of good reviews, and you can tell that the reviews aren't fake either. I mean, some might be, but most of them you can tell people have just bought them and posted a review, and it blows my mind. All right, so that's got a die that's twice the size in it. That's quite interesting. So they don't have the same die in every single one. That's the smallest die I'd expect to see in a TO126 device. There are TO126 devices out there with a die that small. It's usually found in TO92L devices. There's another TO92 device, not TO92L. It's tall and fat and looks like a TO92. You'll find that in that too, but that's just a small TO92 die, even an SMD die. You know, TO92 power parts. So, okay, that's interesting. They're not using the same die in every single one. I would have thought that they'd be the same size. This truly is interesting. Let's keep going. No freaking way. There's nothing in there. Oh, that's hilarious. What was that? That was a BD681. Did anyone know a BD681 is just a blob of solder and a copper heat spreader? You can make them yourself. Oh, God. Maybe that's why it was defective. No way. Oh, no. No, we have a die. The die... Oh, that's a different die again. Hold on. Yeah. That's also like a TO92 size die, but it's one of the larger ones that I've seen. I'd expect to see both those dies in a TO92, and this would be the smallest die that I'd find in a... I don't know, that's still a little bit small for a TO126, but some TO126 devices are really small and do have a die that small, so yeah. But the transistor it was incorrect. This should have a much bigger die. I don't know, it's hard to call. I mean, there's TA92L parts that do an amp and a half, you know, and they have that size of die. So, I mean, if you put that size of die on a heat spreader, yeah, it would get rid of that amount of power. So, I mean, maybe these, because this is what I'm trying to work out. At some point, going down in size, obviously the parts are going to get too small. Like, where's the point in fakery for something that's worth 1 cent? Even if you saw 1,000 of them, it's a couple of dollars, you know what I mean? And then the more you sell, the less you make anyway. So that kind of doesn't make sense. So I'm curious. This is interesting. I was expecting them all to be the same die. Let's have a look in some of those TA92 packages. Why not, right? Why not? I've got some really big TA92L packages and everything, so let's do a bit of a comparison there. I have to say though, for the clone TA126 devices, what I've just seen is very promising. So that's good news. Those are TA92L and whatever the other one devices that I was just talking about are these. I think these are TA92L and these are something else, but it could be the other way around. But as you can see, they're both bigger than a TA92. This is like a 1 or 1.5 amp part. These are 800 milliamp or something like that. 625, I can't remember. But yeah, they go up a bit bigger, you know. None of those are fake, incidentally, so we're not pulling any of those apart. But what we will pull apart is some of these, because I bought some of these kits, and as you can see, these are the little no-name China ones. And remember I showed you the little TA92 ones, and it had B331 and C331 written on it? Well, have a look at this. Do you see how it's always the same format? R133, Y133. You know, it's really obvious. So let's just take, I don't know, let me get another drawer. All right. I'm just trying to think what's going to be, like what should be a different transistor. B647 versus maybe A1013. Maybe I should go have a look at some data sheets. I'm curious. You know what? I'll leave these for another day, because I don't know what these are. I'm not familiar with these particular transistors. Maybe one or two I am, like the A1013. But yeah, I don't know every single transistor in there. So I'll look up data sheets, get familiar with what they should be, and then I'll pull those apart in another video. Let's have a look at a couple of TA92 devices. I just want to see, are the diodes different? All right, I just grabbed 4 completely different transistors. I got an S9013, yep, S9013, BC547, MPSA 92, and a 2N3904. And just again, so you can see what I mean about the clone, fake markings, whatever you want to call them, meaningless numbers, dead giveaway that it's not, you know, what it should be. I'll just let you see these ones, because you'll start to see a pattern. I'll just turn the flash off. Hold on. See, two of them are almost the same batch number, and 2 of them are the same batch number. It's just ridiculous. All right. These shouldn't be too hard to get into. Not at all. Alright, that is the smallest die I've ever seen in my life. That is supposed to be bigger than that. You've got to be shitting me. Although, what transistor was that? It's 9013. That is a pretty small. I'll have to get the data sheet up and look at the collector current. Some of the TO92 dies do get quite small, I'm not going to lie. Like I said, even some TO126 dies are really small. So, you know, it can be hard, as I said a while ago, judging a die just by looking at it. But you can get an idea if you know what you're looking at. So, okay. Those are two different dies. Wow. That's interesting because I've read reviews about, not on Aliexpress, I mean on like DIYaudio.com and stuff like that. And people have bought these little transistors with the 331 batch number and all that and said that they worked. What I'm wondering is, when you get down this small, is it just because any small signal transistor pretty much does the same thing? Is it because they're too small to be worth faking? What is it? Just because people are not really using them to their full potential and not finding out that they aren't real? What is it? It's got me curious. Got a bit of plastic over the die still. I lost the die on that one. Yeah. It was pretty small. Actually, I think that die was smaller than those two. This is good. This is really good. That's surprising me quite a lot. I'm also shocked that one of these was a MPSA 92, because I've trashed those and they took such a beating. Actually, that wasn't the particular one that I trashed. Hold on. Alright, these are the ones that I used when I was prototyping my amp, and they took a ridiculous beating and I couldn't work out why they weren't popping. Let's see if the die's extra big or something. It is. Oh my goodness. Well, there you go. I knew that something was not right. See, compare the die in there to these two dies. Even though these two dies are slightly different size to each other, look how much bigger that die is. And you know what's really funny about this? Look what these two transistors are. Alright, MPSA 92s. And then look at the die size difference. You can't even see the die on that one, it was that small. That's the one I lost the die on, but it was the same size as that die. So when I was using those transistors and I was saying, hey, these aren't popping for some reason, when they should be, I wasn't wrong. I know my transistors. I mean, I've been playing with electronics for a long time. You just get a feel with stuff. And you know if something is blowing too early or too late, you know? And these were blowing too late. And I was absolutely confused, to put it nicely. So that's got a minuscule die as well. Look, these are TO92 size dies. I'm not going to say that there's anything wrong with them. Some of them do look slightly different to each other, but there again, as I've just uncovered, some of the exact same transistor just made by different people have got bloody different sized dies in them. So it seems to be pretty much pot luck what you get. There doesn't seem to be any guarantee of what you get. Yes, the transistors are different to one another, but you might then go get another kit from another brand and the 42s in that kit are different to the 42s in the other kit. So, yeah, it's a shit show. Alright, well, I've drawn a conclusion. The TA126 devices and the TA92 devices are okay. Most of them seem to be fairly legit, but there are one or two that didn't seem to be quite right. You know, like the die was way too big or way too small. But for the most part, they seem to be clones, but they're done properly. As soon as you go up to TO220, you're screwed. All right. Anyway, I would never use these for an amplifier or something like that, you know. I'm going to go and match these now, so I'm going to lay these all back out like I had them before. Let them adjust to the temperature of the surface that they're sitting on, and I'll come back in say 10-15 minutes and match them all, and then I'll come back and show you what I've done. So this solves the current mirror problem and the input pair problem. And when I received these, I think it was yesterday, I can't remember. As soon as I got these and the 2240s, all of these transistors that I've recently ordered of like really high quality audio transistors, like these ones, the ones I've just showed you, I waited for them to arrive to make sure that they were genuine, and then I ordered more. So I've got more coming in, so I don't have to worry about using these up, you know, because I do have at least another 2 amps I intend on building after this one, and just as big in terms of power and amount of channels. So it's going to munch a lot of transistors. This is why I'm stocking up. Yeah, so all right, I'll be back soon. Sorry I get carried away talking. That's just me. I'll be back soon. Actually, whilst I wait for this, I'm going to get a heat sink. I'm going to put some of those tip 41s and tip 42s on a heat sink, and we're going to drive current through them and see at what point they give out whilst I'm maintaining a reasonable temperature. I'll have a look in the data sheet and work out safe operating area now, and we'll see what we can do. Okay, it's actually 1:54 in the morning, so I'll leave that for another video. So this video is going to be a 2-part series. So, because there's a lot more devices that I want to pull apart and compare. I want to have a look at some diodes under the microscope, and I want to put current and voltage, let me explain that in a minute, and do some tests. So I want to do a couple of different tests. One test is where you basically just turn the transistor hard on, pump current through it. You basically want to put it on a heatsink, actively cool the heatsink with a fan, and maintain a certain temperature, say 50 degrees. It's usually thereabouts, 45, 40, something like that. And look in the data sheet, work out the safe operating area for max current at said temperature, and then set your heatsink up for that temperature with the transistor running at that current. And then just basically turn the current up just ever so slightly more and leave it there for a bit. Does it take it? Does it die? That's one test. There's another test where you want to look at basically the power dissipation, not the current handling. For this test, I can do it with 2 power supplies. I can just adjust the base voltage with one power supply and use the other power supply to supply power across the collector and emitter junction. That's basically probably what I will do. For people who are more amateur, I would recommend building an actual circuit, because if you don't know how to calculate gain, all that sort of stuff, you might think that you're doing something with the transistor that you're not doing and destroy it, and then think it's bad, but it's actually just the way you've done it. But yeah, as long as you can calculate power dissipation and gain, volts times amps, basic stuff, you can do it with 2 power supplies. God, I just found something else that's not good. So, like, these devices, these are legit. You see the on semi logo, it's made up of 4 pieces. It's not a solid circle. Well, I was just looking at the output devices on my heatsink. Made up out of 4 pieces. Right? But look at this. They're different. And the writing looks different. Oh no. Don't tell me. We're going to have to pull them apart. There is no way at 250 watts a channel, 63 volt rails with a transformer that can probably stick out, I don't know, 100 amps short circuit or something ridiculous. I do not want anything to go wrong. So I'll go get one of each and I'll pull them apart. Alright, this is kind of annoying me now. These actually do look slightly different, just the finish, not the package or anything like that, but that hole's like really rough inside, that's really smooth, that's dull, that's shinier. Yeah, that is very concerning. I'm just going to do some Googling and just double check that they haven't changed their logo or something like that, because that is quite possible. Alright, I couldn't find anything online. I had a really good look, but no luck. I'm just going to pull them apart. I'm going to start with the one that I think looks dodgy first. You know, because if the die is smaller than what a 150 watt die should be, I'm going to know straight away. I don't think I'll be able to get this by hand, but we'll see. Oh yeah. Oh man, I wish I didn't ruin that now. Onsemi's changed their logo. Damn. That was a very good transistor that I just destroyed. Oh well. Hey, at least we know I'm not going to destroy the other one after seeing that. That's just dumb. That is a beautiful die. Just for record, guys, that's what a die in a 150 watt part is supposed to look like. Alright, pay attention. It's quite large. That's a 150 watt die. Alright, yeah, I've seen a slightly smaller die that's 150 watts before, but only very slightly smaller in one direction, not the other. So just bear that in mind if you ever want reference. I was absolutely shocked then, because I bought them from a seller. Like I said, I've been getting parts from sellers that have been selling me original stuff. So that would have had me horrified. I'm actually glad. Like, you can get good components on Aliexpress for really good prices. You just need to, well, either do what I do, or did, invest a little bit of money doing a bit of research, and once you've done your research, you'll know, you know, straight away what to look for, or ask someone that knows. You know, it's a good source if you can navigate it. All right, well, because I've touched that and because I've been standing here talking over them mainly, I'm going to go for a bit and then come back and then test these, write it all down on that piece of paper there. There's a book sitting here, and sort out my current mirror pairs and input pairs, and then I'm going to work out what I'm going to do for drivers, because now I need drivers. All right, something else has just occurred to me. Remember those TIP 42s that had the full circle around it, but the die was the correct size? But on the curve tracer, all the lines were really close together. Let's put these two on the curve tracer and see if the one that's got the solid line around it comes in a little bit funny, eh? Because it's a possibility that it just has the correct size die, but it's not the right part. Somehow, I don't know how, my USB cable has disappeared. Okay, I found it. Well, we'll start off with the good one. I haven't opened one of these yet, but I mean, after seeing the one I pulled apart looked good, right? So I'm not going to open the one that really looks correct. Unless testing reveals a huge difference between the two, and then I might. Sorry if this video is long, but I'm trying to go into absolute depth here, you know? Alright. Analyzing component. I'll move you guys over to the tripod. If you're wondering, I haven't got a tool tripod yet. I've just taken a drawer of components from up here. Yes, there's another 2 new drawers. And put a tripod on top of it. Alright, back at the computer. I'll make this bigger for you guys. Sorry, I forgot to do that earlier on. So we're looking at HFE versus collector current. I just hope that they look fairly similar. Now, NPN devices and PNP devices do have differences. It's basically physically impossible to make them exactly the same. I'm not saying if you looked at every single transistor in the world, you wouldn't be able to find one that's got the exact same properties as the other one. It's just almost impossible. Even when you buy like a matched set of like a pair, they're not the same. But you know, it's aimed to be close. So that's the first one. That had an HFE of 101. These are supposed to be gain matched within 10%. Although these aren't the same batch number, so I don't know how that works if you've got to buy the same batch. If they even have the same number on 2 devices. I'm not too sure how batch numbers work like that. I think if they're complementary pairs like that, and you've got the 2 in the same data sheet, then yeah, maybe. I don't know. If you know, leave it in the comments. Alright, analysing the next one. This one's got a gain of 98, so yeah, that's quite nice. Considering they're different batch numbers. Let's hit start and see what we get. And that's usually what you'd expect to see. Like I said, PNP and NPN are never the same. But as long as these lines have a little bit of a gap between them, I'll be happy. They seem a lot more close together. Although there are differences. And the worst thing is in the data sheet, it's all in the one thing. At least the curve's following the same curve. That's good. Let's have a quick look here at should be here at the top because I just put everything on sort by modified, so I can have a look at stuff that I've recently added to my data sheets. Oh no, that's the right one, yeah. Okay, so here we go. HFE versus collector current. Is this back to front? 12 amps, 0. Oh yeah, because my tester can't go up that high yet. Okay, that makes sense. So 50 milliamps. Yeah, my tester doesn't go anywhere up near there, so we can't really compare this against this. But I mean, if you look at where these lines are heading to, it makes sense that they're heading to here. So I mean, you can't really say more than that. Yeah, that's annoying. Curve tracer is one of the things I've got coming up soon, like a proper one. Well, I don't know what to make of that. You know, one's an NPN, one's a PNP. There are differences between the two. I could, I guess, grab. I know these are different transistors, and therefore the technology is different, and therefore it's probably not going to make any difference. But sorry, I'll try my tip 41s and tip 42s that are store bought ones from J-Car that I know are original. And let's just see if there's much of a difference in terms of not the curve, but how close the lines are to each other. It's the only thing I can think of to sort of verify this. I'll just clear this. Oh, it doesn't really matter. This is going to be that different anyway. Yeah. I just hope this video uncovers some interesting stuff and sheds light on things. Because I am trying to go into some pretty deep depth here. It's taken weeks and weeks of amassing Aliexpress transistors and a lot of testing and a lot of cracking open cases to come to a conclusion here. Okay, so that was a tip 42. I am going to grab a tip 41 now. I'm just trying to find one that's not being soldered, but it doesn't seem like there is one of those. That's alright. Alright, analyze that. And we'll start. Now I'm going to have to zoom back in again. Yeah, the lines are, you can tell that those lines are close together, but already. So I'm going to say that the output devices that I just tested, I'm going to say that they're legit. I got really lucky there. Because those output devices I bought, I won't lie, the NJW0302s and the 0281s, they were the first time I went to the LSX store that I was talking about. I had never bought from there before. I was just taking their word on it and looking through their stuff and their reviews and the pictures and all that sort of stuff. And yeah, they were real, so that's great. I've gone on to buy a lot more stuff from them and it's been real, so very happy. The same with the other store, CHDX, they sell both. They sell clones and original stuff, but the clone stuff, it's not sold as original or anything like that. Whereas the other stuff is, like, the pictures look totally different. You can tell as soon as you look at them. So at least they're honest. Alright, I'll move you guys back to the desk. I almost forgot. MJE 340, MJE 350. I got these from, I can't remember who. I don't think it was one of those two stores that I trust. And it's funny because they're not steel parts, but I don't know what to make of that. It almost looks like one of them's real and one's fake. So I would like to open one of each up and have a look at the die size, because obviously the die size should be exactly the same. Now, If these are from two different dubious factories, or one's legit and one's from a clone, the die size will be different. So I should be able to tell really easy. Should, being the key word here. Okay, this is promising because it's extremely hard to get into it. This is a totally different type of plastic. This is the more ceramic type of plastic, if that makes sense. If you've been through a lot of transistors, you know what I mean. There's different types of commonly used plastic in transistors. I'm worried I'm going to smash the die. This is really hard to get apart. Oh, I got it. No way. These are real. See, this is only a 1.5 amp part, right? Look at the size of the die. No, it's not that circle in the center, it's that whole square. That's the size of the die. That actually almost looks too big to me. Although this part has to dissipate 20 watts. So actually, no, that is the correct size die. My bad, I forgot about the power. See, that's the thing. It's not just the collector current and the base current. It's also the power dissipation. So let's compare that nice big die to this one. I think these are real. But like I said, it kind of looks like one's different to the other. So I'm not sure. But that one's definitely got the right die in it. Or at least the right size. This is actually the same solid material too. It's coming apart a little bit easier. But this isn't the clone cheap Chinese plastic that they use on the clone transistors. Yeah? Okay. And is that the same size die? Yeah. Okay. They're good. That's great. I will take note of where I bought them from too, because look, I don't need that many sellers. I only need a couple of people to sell good stuff, and I just take note of who they are and I'll keep going back to them, you know. I don't need to keep shopping around. You know, with everyone doing all the dodgy shit that they're doing out there, if someone's selling real stuff, I would rather just stay with them. They deserve to make the money. All right. Now I'm going to finally get these sorted. I just wanted to finish going through all the transistors and be thorough. So, there you go. Those, incidentally, are also for the VAS. I got those and those other three types that you saw for the VAS. I've got a whole load of BD135 and 136 that I just bought. I do want to have a look inside them, but I'm not going to do that in this video because I'm not using those for this amp project. They're not anywhere near rated, especially in voltage, for this project. So we'll look at that in one of the future videos. Like I said, I do want to have a look into some of this in more depth, especially TO220 devices, TO92 devices, TO126 devices. I want to take more measurements, more curve readings, find out how to differentiate curve readings, measure more breakdown voltage. I've still got a lot more stuff I want to do, so we'll just leave it till then. That's all the KC992s. Those VBE numbers are probably just slightly different from temperature. I'd say they're all actually 700. What I do is I double test the VBE after I've selected the ones that have got the same HFE, and I make sure I keep them all held at the same temperature on an object, usually like pinned under something, and then they usually measure all the same. So from experience, I'd say that maybe one or two of those are a little bit different and the rest are all 700. So I'll go get the NPN or PNP, whatever those are that are left done now, and then we'll play matchy. At least there's plenty here and that they match, so that's good news. Also to be noted, the input section I built for this amplifier is just insane. I mean, there is a complementary feedback input pair going into a 4 transistor Wilson current mirror. I don't know how much you guys understand how that works, but that rules out so many imperfections in the transistors. I can get away with a lot worse matched transistors than what I would in, say, just a long tail pair. So considering the circuit I'm running and the transistors I've got, this should work really well. And something else I've been thinking about, you know, when I finally got the input section and VAS to work, I couldn't get more than 10 point something, 11 point something volts of gain. I can't help wondering if it was those dodgy transistors now, because you saw the curves on some of them. It was sort of like going up heaps where the other ones were flat, and both of those curves were wrong, and then some of them did have a bit of a curve at the start and then a bit of a slant, which was correct. Then there was another one where the lines were all together. So I can't help wonder if that had something to do with it, but we'll find out. I can't believe how good this is going. They're literally all matched, the NPN and the PNP, VBE and HFE. And you wouldn't believe this, but I've just ordered another 20 or 25 of each from the exact same supplier. So that is absolutely wonderful. All right, that's that done. So that's what I've got for the 1845s. A lot around 415 to 425. VBE 700. And guess what? Same thing here. So I'm not going to bore you guys and show this on camera, because I mean, seriously, what? I'm going to grab a whole load of the same HFE of 2 piles and stick them in bags now. So I'll do that and then I'll come back. Well, that certainly didn't take long. I've got 2 sets of input pairs ready to go. I mean 4 sets, you know what I meant. So that's that's just amazing. I am so happy. Seriously, I mean, that just worked out so well. These are all the same. These are all within 5 HFE and the exact same VBE. I mean, you cannot get better than that. This is so impressive. HFE is 430 if anyone's wondering. So that's what the gain is now. 430 on the input pairs. And I'm happy with that. So now we just need current mirror transistors. That's simple. I just need to get a whole load of 1845s that are the same as each other. And I can go for a little bit lower gain, I guess. It doesn't need to be as high as these input pairs, but it still needs to be not really low, I guess. So the current mirror are 1845s, aren't they? Yes, 1845s. So I'll just work out what I'm going to do and I'll come back and give you the results. I just had a thought come into my head. Those tip 42s that looked like on semi that I think were fake, where I curve traced them and the lines were really close together, and I said, oh, okay, they might be fake. Sorry, one sec. I just realized, remember how we tested NPN and PNP and the lines were closer together on either the NPN or the PNP? Maybe that's what happened with them. So maybe they are real. I'll just have to, you know, do more testing, do more research. This current mirror, here's what I've got left. Now, I want to make 2 sets and I want all 4 transistors to be matched to each other. I could do it out of this, but it wouldn't be as closely matched as what I want. I've got 2 options here. I have these that I got off of that amplifier board. Now, I can't remember how close these were, but yes, they're all from the same batch. I've got 2 options here. I can take the rest of these transistors off that board, match them, use them, or I can wait 2 days, the weekend, until Monday, because on Monday I get another delivery and I'm pretty sure the second lot of these, well, you know what, it could be a few more days away. I can't think. I didn't order these. I thought I ordered them yesterday when I got them, but no. What I did was I ordered a few different transistors at different times. When original transistors started rocking up from a certain seller, CHDX, I think it was, I went and ordered more of these from them before the first lot had rocked up, just because all the others were not fakes, you know? So, that being said, it could be Monday, it could be Tuesday, it could be Wednesday at the latest. I don't think it's going to be later than that, but I don't know. I think maybe I should just go through this board. It looks quite promising. They all seem to be around 400 and something to 500 and something. Yeah. It's literally 3:30 in the morning now, so I'm not going to do this tonight. I'll come back in the morning, take all the transistors off that board, see what I get, and if I can build 4 transistor current mirrors where all 4 transistors are matched, you know, I'll do it. The reason I want them all matched is because if you think about it, you've got 2 current mirrors essentially on top of each other, right? Now, what are they doing? One's trying to copy the current on one side to the other one's trying to copy the current on the other side to the other. If one's got more gain than the other, that is not going to be an even action. So the way I see it, all 4 should be matched. If you know different, correct me in the comments down below, but that is my understanding. Like I said, when you've got complementary feedback input pairs and 4 transistor current mirrors, you can have more mismatch, yes, but I'm still trying to do the best I can do here. The other thing I've got to consider is what to do about the drivers. Now, to be honest, tip 42s are overkill for what I'm doing, but those other transistors that I've got, these guys, these are underkill. Something in between would be good. The funny thing is, the dies in those tip 42s and tip 41s is roughly in between the size of these dies and tip 41, 42 genuine dies. So maybe I could use them. Although, actually, you know what? They were the same size as the die in this, weren't they? Hold on, let me go get the dies. Alright, these are basically the sizes of the dies. I think it's these 2 that I've got in my amp. So they're way too small. I think they're smaller than the dies that were in there, but I can't remember. I think that was 2mm. I can't remember. I'll have to go back and watch my own footage. These certainly are not 2mm. Yeah, that's like 1mm, 1.1 1.2, maybe 1.1. Yeah, 1.1. Yeah. Maybe, just maybe, but no, they're too small. I thought they were a little bit bigger than what they actually are. And I was going to say, look, they might work, but I don't want to risk destroying all my output devices. I think it's a silly call to make to try and use these in an amplifier. At least one at this voltage level and power output. So what I'll do, I've been having a look in the J-Car catalogue because I was thinking about going to J-Car tomorrow. The thing is, I already know what tip 41s and 42s they've got there. I've got the exact same ones here. If I wanted to use them, I could just use them. Their ones are the exact same as what I've got. They're not matched. They've got MJE 2955s and MJE 3055s in TO220. They're 75 watt devices. They would do great. They're overkill. They're 10 amp devices. The collector voltage is only 70 volts. Yeah. I don't really feel too comfortable about putting that on a 63 volt rail. It might hang in there, but let's not be like that. Tip 31s, tip 32s. Their HFE is even lower. God, 25 to 50. Yeah, that's not... I don't really want to go down that route either. Let me go have a look at my Aliexpress orders and see if I've got any other transistors coming or if there are any more tip 41s and 42s coming. I don't think there are, but I've got to work something out. So let me have a look. All right, I had a look. I've only got one more lot of guaranteed good transistors from that trusted seller. 2SA 1480 and 2SC 3790. They are going to be for VAS stage usage, not for driver stage. So yeah, that sucks because I just ordered a whole load of transistors for the VAS, not thinking that I had driver issues because I had so many tip 41s and 42s and they're all bloody fake. So I don't know what to do really. I'll go into J-Card tomorrow. I'll take this guy with me. I'll see what they've got again. I might just grab a little bit of everything anyway because all my 31s and 32s are going to be fake that I've just bought. And I've got multiple drawers of those too. I've got these ones that just got topped up from that box I bought. And I've got a drawer over the back that's got original ones that I've bought. I've only got 131 and 132 left. So I need to get some original real ones anyway. So I might grab some of those and some 41s and 42s, just a couple to add to the pile I've got because they're probably going to be the same ones. And I might grab some of those MJE 2955s and 3055s. But I don't know. I might not grab anything. I might look somewhere else. I might go to one of these sellers that I've got the good devices from and see what sort of driver transistors they've got and order something from there. I don't want to spend too much money on stuff that I'm not going to use. I don't mind buying big amounts of stuff if I know I'm going to use it. But yeah, it's a tough call. The thing is, when you go and buy transistors from shops and stuff like that, they're not cheap like when you buy them in bulk or even in small piles off AliExpress. You got to understand the people who sell like these, for example, they would have bought a couple of reels, thousands of them, and they work out to be cents a piece. They can sell them for a few more cents a piece. You go to these stores, they charge through the roof. J-Car wants $14 or something. Let's have a look. I'll show you. I'll show you how crazy it is. I'd have to go DigiKey or something and put a bulk order in to beat this. So MJL 21194s $14.50. MJ2955s are $2.75 each. You guys know me. I buy like 20 something at a time. Could you imagine me buying 20 of those? I'd be broke for a month. Yeah. I'm going to have a look around tomorrow for driver transistors and work out what I'm going to do. I might end up doing some destructive testing on these tip 41s and 42s. See what they can actually handle. If I can do destructive testing on them and they turn out to be, say, a 4 amp part or a 3 amp part or something like that, and the curves check out good on them in terms of linearity and all that sort of thing, gain versus collector current, all those things, I might use them whilst I'm waiting for something, but that's sort of just me being impatient, and I've made that mistake too many times in the past. It's better to just wait than destroy output devices and my whole input section. Although, to be honest, the input section probably won't get destroyed in this kind of circuit, but yeah, I don't want to go throwing my output devices, so I think I'll just wait, see what I can get tomorrow, and if I have to order something, I'll just have to wait another week, so be it. Alright, I'm going to go to sleep. I'll be back in the morning to continue matching and sort out drivers. Alright, I'm back. It's the next day. I'm taking the transistors off this board here. I know it's mucked up and yucky from being outside, but everything's all good. Well, not everything, I mean the transistors and the things I want to take off of it anyway. I mean, that's 4 I've already pulled off the board there. They're fine. So, anyway, I ordered transistors today because I've now got a couple of sellers I found on Aliexpress that only sell legit stuff. I trust them. So, I've gone and bought tip 41s and tip 42s from them. I've also bought from the same sellers, so there's no question about these components that are coming. These will be like the other devices that I showed you earlier on in this video that are legit. Well, they're coming from the same seller too. I've ordered 2SA968 and 2SA2238. I used to have a lot of those transistors, used to use them, so I'm quite familiar with them. I also ordered 2SA489 and 789. I've never had those, but I grabbed some, I had a look at the data sheets, they look quite helpful, and I was able to get some of those. So I've ordered 3 lots of transistors, roughly about 20 of each. I can't remember, maybe the tip 41s and 2s I might have got 20 NPN and 20 PNP, I can't remember. Maybe only 10 of each, I can't remember, to tell you the truth. I think I did get 20, because I know that they're going to be proper ones, not dodgy ones. So in at least a week, could be less, I'll have all the components to build this amp. And the reason why, if you're wondering why I bought, you know, stuff like MJE 350s and 340s and just a lot of the transistors that I've got, and these ones, like the more higher end ones and some of the old Japanese ones, is because I want to go all the way with this amp and make it really high end, you know. I've done a really good job on the input section. I might as well keep going, you know. There's nothing to say that I won't, oh, ouch, I hate that. Sometimes you get a transistor too hot and it heats up and it burns your finger. I might even end up doing some mods to this amp. Like I might end up spinning up another board that's got, I don't know, like more, what do you call it, complicated current mirrors, like 2 transistor current mirrors or something like that. I don't know. Who knows? I don't know myself what I'm going to do just yet. But anyway, I'll finish taking these off the board off camera, and then I'll come back and start matching them. This board's going to make a terrible mess. I'm going to have to clean up. There's all dirt coming off of it and rust. I've remembered where I got this from, because I used to do scrap metal years ago, and I threw a whole load of things out in the scrap pile that were for the rubbish. And then when council cleanup stopped happening around here, I realised I couldn't get boards anymore. I went out and grabbed a few things that are out there for a few years. This was one of them. And as you can see, even though most of the stuff on here is ruined, the transistors are fine, you know. That NTC is probably fine. Those two diodes are probably fine. That big diode's probably fine. The 494 is probably fine, you know. These two big caps might be alright. Those two diodes are probably fine. The transistors I'm taking, I probably wouldn't take much more than that off of here. Maybe these NTCs too, thermistors, whatever they are. You know, everything else I'd leave, because it's a lot of components have steel legs, you know, like capacitors and stuff like that, and this is yeah, a mess. And also you got to think about moisture ingress too, what happens inside the components. But anyway, you'd be quite surprised how much electronics can actually live up to the environment. I'm not saying when it's switched on, because you're going to get current flowing between all different paths, but I'm saying if you just take a handful of components, or mainly silicon devices to be honest with you, and you just put them outside, you'd be quite surprised. You'd think that they all the moisture and the oxidization and stuff would get straight up the leads and into the silicon, but in my experience, the only time I've ever found transistors where the silicon seems to have been damaged from stuff growing up the leads have been transistors that were like at least 40 years old, maybe older. So I can tell you now, like, yeah, it's not something you should do, get your stuff dirty, but it's alright. If you find the dirty board, don't be put off salvaging components from it like transistors. Obviously, you should test them all, you know, and if one or two of them seem dodgy, toss the whole lot, because, you know, they could be just about to develop leakage or something like that, you know. But, you know, if they test fine, don't worry about it. I've never had a problem. If they're maybe 40 years old and in this condition, then yeah, okay, maybe you might have cause for concern with stuff making its way into the transistor. But yeah, I certainly haven't come across it with any of the boards I had outside for a few years on the rubbish pile. Had to grab the legs really tight on that so I could pull it by the legs, not the package, otherwise it was going to come out by the I was going to rip the legs off the transistors, what I'm trying to say. Alright, one more. I mean, there could be a couple more. I'll have another look, but I think this is it. Hopefully it's enough. Should be. Alright. Just clean my soldering tip up because this board is absolute rubbish. And I'll leave this off to the side because there's only, like I said, just pointed out, there's only a couple of things I'd take off of here. I might take these polystyrene caps too. Obviously I'm going to do breakdown voltage testing and stuff like that, but it doesn't look like moisture can get into these. So yeah, probably take them as well, but I'd leave everything else on there. I've got plenty of other boards for salvaging stuff, so the only stuff I'm interested in taking is stuff that's actually like worth taking, you know. But yeah, I'm just going to take this mat to the bin and clean it off. I'll be back in a sec. That's better. Alright, let's see what we've got with these guys. Now I do have these two match sets and some in here too, don't forget. And all these ones I matched yesterday. I know you were probably all thinking, Dave, write it on the thing. Don't worry, I did. I wrote all the numbers that, you know, VBE is all the same on them because they're all matched. So it's just 700 I wrote down the bottom, and the HFE I wrote underneath each transistor. So they're already done, you know, and these are already matched. So it's not like I just have these to select from, and I only have to make up current mirrors. The thing that is slightly annoying about it is it's all 2SC1815 or whatever they are, KSC1815, 45, sorry. Getting a bit hot in here. Hold on. That's better. So, anyway, let's see. This is still a bit dirty. I'll have to clean it again. It'll do for now, however. You know, I remember, I think those two had higher gain than the little ones. They were like 560 or something like that, and the rest were in the 400 region. So I'll start off with all these little ones. And I'll just get a piece of paper here too. All right. Five, 6, 8, 6, 9, 2. Oh yeah. I haven't straightened all the legs out with pliers yet, so it's a little bit annoying trying to grab onto them with the clips, but it's alright. 540, 695. So maybe it doesn't matter which ones, they're all up there in gain. Did I touch that transistor? That VB is really different. Really? My other batch of VBE is all 700, although that was at a different temperature. So let's have a quick look what the VB is today, because it's actually quite warm in here today. I mean, in the grand scheme of things, it's not warm, but compared to the last few days, it is. So yeah, these are now 696. Oh yeah, still pretty close. Hey, can you get the on? Thank you. All right. Oh, that's actually what these ones are too. Wow. Huh, I'm getting really lucky with these, I tell you. Considering like I didn't have many and all that sort of thing. We're getting lucky with the ones that I've bought and found on the board. That's really good. I'll go do the rest of this off camera now because I just wanted to come on and talk about a couple of things which I have spoken about now. So I'll get the rest of this done off camera and then I'll come back and take it from there. All right, I've done those. Still not the greatest selection considering what I've got here and what I've got there, but we've got something. I'm going to go through the drawer now because I'm pretty sure there's just a couple of lone 1845s in the drawer. So we'll see what's in here. And then I will see if I can match 2 sets of 4. If I can't, I'll just wait. What's today? Saturday. The day after tomorrow, I should get the rest of them, so it's not that long. You wouldn't believe this. They are all KSA 992s. There's not a single 1845 in there. There's a couple here, I guess. These are around 350. I already know that. I guess there's no point in really measuring them. I'm pretty sure these are around, 350. Yep, I'll just keep these as they are in matched sets. Alright, let me have a look at this and analyse the data and I'll see if I think I can pull this off or not. I don't have any there. I'm going to have a quick look and see what these are like. These are the KSA 970s and KSC 2240s. These are really, really nice transistors too. I think the 992s are the best, but I'm not too sure. Like out of these couple that I've got here. Four, three, four. 469. 516. I think I'm just going to wait until Monday. Yeah, I'm just going to wait because I've already got, oh shit, that came from there. I've already got all of these, right? These are all 1845s. I might as well wait till Monday. I'm going to have exactly 20 more of them. They'll probably be from the same batch as this too, so they're going to be the same as the numbers on here. So, you know, yeah, I might as well just wait till Monday and just, yeah, do this on Monday. It is what it is. Yes, it can be quite hard getting matched pairs of transistors. That's the way it is. But, so be it. This is why when I buy tip 41s, see some transistors you're more likely to find matches of, and some are made with tighter tolerances. Others have more broad tolerances. Tip 41s and 42s are a really good example of that. That's why I try and buy small numbers, like 10 or 20 of them from heaps of different people to try and match sets. But yeah, the art of matching transistors can take time. Well, we are getting there. So far I have, what have we got? Input pair, input pair, input pair, input pair. 3200s, 3200s, fast, match set, current sources, current sources. You know, that's already quite a lot of matched transistors. So it's, I can't complain, you know. I'm building a kind of intense amplifier here that's got some intense circuitry and it requires a lot of transistors. So, you know, when you're trying to build something like this and you want everything to be all nice and matched, it can take some time. Even when you have crap lying around, buy a couple of batches, it can still take some time. So, I guess we're still waiting. It's only two bags that have got, wait a minute. What am I thinking? I need 4. Shit. This might be a bit of a problem. I didn't think about that. I've just realised something. I actually need 4 sets of 4 transistors. So that's 4, 8, 12, 16. Oh, I'm not going to get that out of what I've got coming. I better go order some more quickly. Good thing these don't cost much. Jeez. Yeah, I didn't think about that. This might have to get put off for maybe 2 weeks. Oh no, wait, what am I saying? If I order them today, it's still going to be a week. Jeez, I say silly things sometimes. I'm going to get on that right now. I'll be back in a sec. I will just add an additional 2 bags for the current mirror transistors, so when I go to match it and bag them up, I don't get confused and only match 2 sets, because that won't help me. It's a lot of transistors. I'll be honest, some of the transistors in here I didn't have to match, like the bigger ones back here. But at the same time, it doesn't really hurt. It helps because then everything's identical between all the channels of the amps. So then if there's some difference between one channel to the other, You know it's not your transistors, well, unless one's faulty, right? Yeah. All right, I'm going to pack these up, and then I'm going to do one more thing in this video, which is going to be some destructive safe operating area testing, basically. I was just looking around my lab thinking, okay, what else do I have in the boards pile that I can strip? I have this. This is off of a mixer I had years ago. This is just the front of the mixer, like literally just the front panel. There's a board missing off of here, the DSP board. The rest of this works, but there's no point in me keeping it. This is just in my boards pile. You know, because the sheer amount of parts that are on it, it's a really good haul, you know what I mean? Guess what this is packed with? Op amps and transistors. I've just had a look in the side and I can see that they are C1815, so not 1845. I'm familiar with that transistor, but I'm not familiar with its voltage rating. I can't remember what it is, so I'm just going to quickly check. Oh, shit. And if it's high enough, I'll use those for the current mirror, if there's enough on there to get matched ones out of. It just depends. There could be 5 or 10 on the board. There could be hundreds on there, so I'll suss that out now. Right, so it turns out that they are 1815s in there, and they are 60 volt parts, so no good. However, for these transistors, you want to know what I've paid for 10 pairs? Grand total of $5.70. So I'm going to go order like, I don't know, maybe 4 lots of them, 20 bucks worth roughly. It's not very much for a good quantity, and I'll be able to get a lot of match sets out of that. So I'll get that done now, and then come back and we'll do the last thing, which is going to be destructive testing. I just want to know what some of these devices do. I just had a look to see how long this video has been. I didn't realize it had actually been this long because I've recorded it in a whole series of segments. So I'm going to end the video here. I want to do some more in-depth testing, so tracing different curves and pulling apart a lot of TO92 devices and TO126 devices. I want to do safe operating area tests, so controlled temperature heatsink and then controlled power to transistor. I explained the 2 tests I wanted to do before. One for power basically, and one for current handling. And obviously breakdown voltage tests and all the other tests too. But yeah, that's going to get left for the next video, because if I did that in this video, it would just end up being hours long. So that's it for now. Don't worry, I've got plenty of other things to do. I've actually just got 3 more chips out for the breadboard data sheet to breadboard series. Just as a little teaser, I'll let you know that there is a ICL 7660S charge pump, an LP51 ACN I think it is, reference IC, and an AD737 true RMS converter thing. I can't think what it's called. So those videos will be getting done too, so stay tuned. Alright guys, I was watching a video by Tony, the guy that fixes amplifiers. I've gone blank on his channel name, but you'll know who I'm talking about. I know there's a couple of Tonys, not Tony359, not Tony Albus. I can think of all the other ones, but the one I want to talk about. You know, the older guy, it's not that old, probably 50s, curlyish hair, greyish, curlyish hair, fixes amplifiers in America, I think he is. Anyway, he's got one of these testers, and I saw him testing transistors on it, and it does a lot of useful tests, that way more than what you can do on that thing. Well, sort of. It's in a different way. It would be really handy to have both of them. This can source a lot more current and voltage and things like that, so yeah, it's going to be good. It can source 100 milliamps for one thing, not 10. So I've ordered that. So that'll be here in a week, and that will be part of the next video where we do destructive testing and more testing and all that sort of stuff on these transistors. Alright, well that brings me to the end of this video, so excuse me, I'm going to conclude that here, and I guess I'll see you all in the next video. Thanks for watching.